Hello guys, I'm Nishtha Saxena, student of Mechanical Department of IIT Delhi, and I'm going to present on charging system in a car. So let's begin with it.
So here we are on the presentation on car charging system in a car, presented by me, Nishtha Saxena. So let's focus on the advantage of the car charging system. So as we see with the the technology is increasing, and as the technology is increasing, the need of electrical system is increasing. High power and voltage requirements is increasing because it is used in the cooling fans, the AC, the rear camera, DVD player, USB port. All these work on the electrical systems. We'll see in the next snippet how and where the electrical systems has been used in a Baleno car. Hello, so guys, here we are in the inside of the car, and we are only focusing on the electrical components of the car. We are not starting the car because I don't know how to drive. So let's focus. So as we can see, there's an LED, the Bluetooth or Wi-Fi or AC or the rear view camera, the lights. These are all very minimalistic components that are electrically driven in the car. So that is why we need battery, and because the engine is not on, since the ignition has not started, so this is all being handled by the battery. We'll focus more later when we'll go through the presentation. So the model of car charging system. What happens that when engine is not running, in this case when the engine is not running, the alternator voltage is less than the battery voltage. So current flows from the battery to the load, and alternator diodes prevent current flowing to the alternator. So there is no current flowing to the alternator, but the flow is from battery to load when the ignition is on but the engine is not running. When the engine is running over here, then the battery. So when the engine is running, the alternator output is greater than the battery voltage. So what happens that the current flows from the alternator to the load. In this case, when the alternator voltage is higher than the battery voltage, so it flows directly to the load, because we don't want the battery to get discharged, and it should keep on charging on the other hand. So the alternator voltage goes to the load, and it also charges the battery on the other hand. Let's focus on one video and understand the complete. So here, as we can see, a motronic or ECM motion from the wheels will get transferred to the alternator. The alternator will convert the mechanical energy to the electrical energy, and this electrical energy will go to the battery and charge the battery. From alternator to battery, there would be the least resistance possible, so that there is no energy loss. And once the battery is getting charged up, the alternator will send another signal to the warning light. From the warning light, there are diode connected. If there is no warning, then it will go to the then it will pass to the fuse panel, and there will be no warning. If there is some problem with the battery or the alternator or anything else, then there would be a warning shown. Let's view the video. So here the motronic or ECM motion is transferring the energy to alternator through a duty cycle. The battery is getting charged, and the warning light signal has been set. And come back to our presentation. We have understood the model of car charging system. The real world design. So the real world design actually depends on the car model. It may not be necessary that everything will be in the same way as shown in the picture. But what happens, there's a driving belt, and it transfers the mechanical motion to the alternator. The alternator converts the mechanical to electrical energy, and then there's a charging relay which charges the battery, and the ignition switch or ignition light is basically to start the engine. The engine then will move the wheels, the belt, then the alternator, battery, charging relay. Fuses are used to safeguard the system. The voltage regulator basically controls the voltage. if the voltage is enough to charge the battery, then only the battery will be charged. So basically, alternator is to generate the electrical energy, voltage regulator to adapt the control voltage, and engine controller is basically to adapt the control speed. What is the, so there's a minimum speed after which only enough current is produced so that the battery could be charged. Here's a, because alternator plays a very major role, so we'll discuss about the alternator. It is basically a system like this. As we study in school, there's a kind of, from here there's a motion, a circular or a anti-clockwise motion, and this this wiring rotates, and here's and a magnetic field is produced which converts the mechanical energy to the electrical energy. For that, there's a stator, the rotor to rotate. There are slip rings to maintain the easy movement of the coil. So the alternator is basically a AC power generation. As it rotates, there is a positive cycle and there is a negative cycle. For the positive cycle and there is a negative cycle, and it is also known as synchronous generator. So the coil rotates, the magnetic flux also changes accordingly, and hence it is converted to electrical energy. Now we'll see on what things this this charging depends on. So you can see the alternating current. So we'll now see on which the charging depends on. You can see there's an alternating current. As the current increases, the engine speed also increases, and as the engine speed increases, the rotor will move faster and the battery will be charged more quickly. So the thing is that when the charging current is greater than a limit, the battery will be charged. Else the battery will be discharged in using the loads, as we saw in previous slides. The charging also depends, we know that it is directly proportional to speed, and up to a current limit the battery is discharging, and then it charges, because now the alternator is handling the electrical appliances. So there are cases of undercharging and overcharging. We'll look why there is undercharging, why the battery is not charging at the right in the right span of time. So there may be short driving trips, like we are only driving for like 1 kilometers or 2 kilometers, then the battery has to first regain the speeds, the battery should start charging, and as soon as the battery starts charging, you just shut down the engine. So this is undercharging. There's the generator is defective, the voltage regulator is defective, the voltage regulator is not sensing the right voltage for the charging. The wiring, there should be minimum resistance, low engine RPM, you can understand, excessive accessories, the usage is a lot, so there's more discharging than the charging. Now overcharging is basically when there is a defective voltage regulator, then there may be it is not sensing the right current voltage, and the voltage is above the limit that the battery could handle, or there's a sudden voltage drop due to voltage sensing wire, or there's voltage drop in regulator ground. So these are all the reasons for overcharging and undercharging. Now when charging system fails, when will the user get to know that my charging system is not working properly? Then you must have heard, when you start the ignition, there's some issues, the ignition is not starting, and then people have to push from the back and all this stuff happens. It is because the charging system is not working, because charging system is responsible for ignition. Dim or flickering gauges, you must have seen the headlights are dim, or the headlights are not working properly. This is very normal things that a user can understand. The charging is not, there's also gen bat and alt warning that the system gives. Now, what are the future aspects? What can be changed, or what will be used further in the charging? What will be the changes? So you can see there are better power output. We require more power output from the battery. Increased electrical devices. The devices are increasing at a very humongous level. So the luxurious cars are like, nowadays there are electrical vehicles. The luxurious people are, the rich people are buying electrical vehicles, and the electrical vehicles require battery for everything, for even running the car. So in that way, we have to look for the charging of a battery, how it is charged. It should not, it should work properly. It should not discharge easily. Less in fuel consumption. Due to this electrical system, the fuel consumption is less, because most of the things are handled by the electrical systems. Spacious. With the increment of the usage, the battery size will also increase, but the battery size should not increase too much that the car is like 90% of the part is just focusing on the battery part. So that's a very limit. Now let's focus on the conclusion. The conclusion is that every car needs a charging system. There's undercharging and overcharging that happens, that the user should understand, and when it is not working properly, then the battery should be replaced before the user is not able to run the car. So everybody knows that necessity is a birth of invention. I'll end this PPT on this quote, that as we need new appliances in the car, as we need new technologies, the charging system will definitely evolve. These are the references. Thank you.